Welcome to Make Made Simple. Today we will be studying what is the friction force. So, the friction force only exists as a reactionary force. That is, it has the property of reaction. It has magnitude and direction. So, we will be studying two cases. First is not moving static case, and the second is moving kinetic case. So, if we are applying a force F on a block M, then there will be these forces acting on them on the free body diagram. Mg towards the down direction, that is the weight of the object, and the reaction force N, that is Mg. So we will have the friction force equals to normal reaction force into the coefficient of friction. Now, in this case, the mass of the object is 10 kg. So, mg weight of the object is 10 into 9.8. I have taken 9.81 equals to 9.8 meter per second square, which will give us 98 Newton. Now, for calculating friction force, we will have the friction coefficient, static frictional coefficient is given, nu(s) is equal to 0.5. So the frictional force will be N nu, that is 98 into 0.5, that will give us 49. So that is the maximum magnitude of the frictional force that is being uh, happening in this object. The maximum friction force that is being occurred in this object is 49 Newton. So if we apply if we apply a force of 10 Newton here, then this will not move. If we apply 20 Newton force, then the frictional force would be 20 Newton. When we will apply 30 Newton frictional force, then the frictional force will be 30 Newton. When it is 40, then it will be 40 Newton. When it is 50, the frictional force is 50, and when the frictional actual force is 49, then we are seeing a 1 Newton gap difference, 1 Newton difference here, which will actually cause the body to move in this direction. So we will be considering the kinetic moving uh, force, moving case here. So we are seeing from this table here that until and unless the force exceeds the maximum magnitude of frictional force, then only the object will move, otherwise it will not move. So that's the case here. Now for the kinetic case, we have a normal force here, and which acts in the upward direction with magnitude mg, and weight is mg, frictional force is n nu. Nu in this case is smaller. Mind you, this nu is smaller than the static case, which is 0.5, and in the kinetic case it is 0.2. So F frictional in this case is F frictional equals N nu K equals N is 98, we had calculated from here, and nu K is 0.2. So friction force comes out as 19.6 Newton. So this is the friction force that is being applied here when this object is moving in this direction with a force of force applied is 50 Newton. So now the next question is, what would be the acceleration when this force is being applied. So acceleration is F net by m. So applied force is 50, friction force is 19.6, and the mass m is 10. So this will give us 30.4 divided by 10. This will give us 3.04 meter per second square. So this is the acceleration that is being produced in the body when a force of 50 Newton is acting on this. Friction force acting on this object is 19.6 Newton, and acceleration is 3.04 meter per second square. So from the crux of this lecture was that until and unless we reach the maximum magnitude of frictional force applied to the body, that is equals to nu s and nu s, until then we will not be able to move the body. When the force when the frictional force exceeds when the applied force exceeds the frictional force, then only the body will move. So that was all for today. Let's meet in the next lecture. Till then, bye bye. If you have liked the video, please do like the video and subscribe to my channel. Make made simple. Thank you.